Sure, thank you. So we would start. Good evening. As you are aware, my name is Akosua Nyarkoa, and I'm one of your mentors for the AI and language categories. For this evening's session, we are going to be discussing how we can leverage language technologies to develop inclusive solutions, right? Yeah. Please feel free to unmute your microphone if you have like any comments or questions, right, that you would have in the course of my presentation. Yeah. Okay. So the language is one of the main ways in which we communicate as humans. In the society, we're able to communicate, access information, learn, use services, right, within our environment by virtue of languages, right? And when we have technologies, right, that we use which do not adequately support the languages that we speak, then you'd realize that there is some sort of barriers that are created with regards to the use of the language, sorry, the use of the technology. Okay. Now, many Ghanaian languages are low resourced, okay, or they are categorized as low resource languages. And what we mean by a language being low resourced is that you know, the language can be that language can has some crucial limitations, right? With regards to language modeling on the digital space. So one of the limitations that such a language will have is that there's a scarcity of labeled and unlabeled language data, right? Aside from the fact that there is a scarcity of language data, right? The second crucial limitation factor is that the data is of poor quality, okay? And usually we talk of poor quality in the sense that it is not sufficiently representative of the languages and the socio-cultural context that the language is known for, right? So you realize that this creates very interesting opportunities for solutions, especially with regards to this particular hackathon. Okay, and before I move on, I'd also want to draw our attention to one very broad concept, right, that we may be aware of: language technologies, right? So when we talk about language technologies, we are talking about technologies that enable computers to work with human languages. Okay, now these technologies could cover large areas, which include basic components such as writing systems, spell checkers or grammar checkers, right? And then we have that language technologies have, like, let's say, three main areas. Okay, so the first one, we can talk of written language processing, right? Some people may call it natural language processing or computational linguistics. Okay, so we'll talk about that more, but I think, in fact, for this session, right, we'll be focusing more on the written language processing aspects, right? In the morning session, you also saw some other branch of language technologies, which was spoken language processing. Okay, so that is where you had your speech recognition, right? So in the session in the morning, these were some of the things that you came across. Then we can also have a third category, which is sign language processing. Okay, so that's in terms of analyzing sign languages, generating and then translating sign languages. So all of these things, as I'm mentioning, you'd realize that they provide very interesting opportunities that you can think about ways where your solution could fit. Okay, and then examples of low resource languages. I think I didn't give that. We could have the Ghanaian languages we have. So we could have Ekoso, Dagbani, Akan, Ewe, right? Those are low resource. And then we have high resource languages, which are the ones that are sufficiently resourced in terms of data and its representation. So English, Spanish, French, and so on. Those ones are examples of high resource languages. All right. So moving on, yes. So we have, two main barriers. Okay, as far as this hackathon is concerned, these are some of the two main barriers where that contribute to digital exclusion, right? So the first one is the language barrier, and the second one is accessibility barrier. Okay, and the language barriers, we have unfamiliar language, difficulty to understand languages, limited local context, right? So unfamiliar languages, we these are like the simplest to probably understand. Okay, so this is a case where a person does not speak or understand the language that the system or an NLP system or solution you'll be developing would make use of, right? So you'd realize that a user typically would struggle to use that system. So let's say the Ga community, a community where we have Omega speakers, and then there's a technology, right, that is in English. You'd realize that although the technology could be solving a problem that they have, they wouldn't be able to really use the technology as it should, just because the language is in a language that we do not understand. Sorry, they are unfamiliar with, right? Then difficulty to understand. So difficulty to understand, we are thinking in terms of, we have at this point, the language is familiar to the user, but then the terminologies, right, that you are presenting the information, right, for your solution is not simple. So it means that these complicated technologies make it very difficult for a user to adopt your solution or to even use your solution. Then we have limited context, right? So you'd realize that one problem we have with language technologies is that they might actually recognize the words that are being used. Okay, that a user is uttering to them and stuff like that, but then they will still struggle with the meaning or context behind some of these utterances that users are making, right? And when you move to social media, you realize there's sarcasm, right? Somebody might say a sentence, but then the meaning is something completely different. So you realize that language technologies usually struggle with that, right? Another example is let's take an account phrase, right? So you could have an account phrase like "Odenihua Kangura." If you should translate that term literally, it could mean that somebody has touched, for example, a leaf or a weed, right? But then in terms of expressions, it could also mean that what somebody has run away. Okay, so although your language technology may recognize the words literally, that okay, somebody has touched a leaf, right? It could mean something else, which is something that language technologies struggle with, and that could also contribute to language barriers. Okay, then we move on to accessibility barriers. So in terms of accessibility, we are asking whether people can actually interact with the technology. So is it a technology, a system that like a user is able to perceive? Is it something they have difficulty to navigate? Is this something that is difficult for them to understand or operate? Okay, these are some of the things you need to be thinking about when you're designing language technologies, right? So inclusive solutions consider both language and accessibilities, right? All right. Do we have any questions at this point? All right, so I'll take that as we have no questions. So from problem to prototype, right? So I would want us to, or this is a recommendation anyways, to look at this 6-step processes, right? We start with the problem, we identify the user need, we define the solution, identify a language task, choose the appropriate technology, and then we finally determine what we can realistically demonstrate as a prototype. Okay, so let's take them one by one. The first one is the problem. Okay, so far in the series, we've been introduced to how we can identify problems, right? So I wouldn't talk much, but then at this point of the problem phase, we are looking at, or we are asking ourselves as teams, what communication barriers exist? Okay, remember that for this impact track, which is the AI and language categories, we are looking at mostly eliminating some of these communication barriers that exist within the Ghanaian context or the Ghanaian language context. Okay, so what communication barrier exists? You'd realize that this is where you'd actually identify a particular challenge. So, for example, you have people who speak a particular Ghanaian language, right? However, they have difficulty in accessing important information. That is because um, you may have noticed that the available digital service only communicates in English, for example, and that is a problem. Okay, that's you and your team may have identified. Okay, so that is the first step. Once you've been able to identify your problem, then you move on to user need. Now, you should be asking yourselves, what does the user actually need to accomplish? You'd realize that every user has a goal. Okay, so for example, a goal could be that they need to understand some information, they need to ask a question, they need to translate some information, or even communicate with another person. Okay, so you need to be able to um, identify that, right? Then the third one is solution. So at the solution phase, you and your team should be asking yourselves, what will your application or what will your solution help the user to do? Okay, so for example, a team could come to the conclusion that their solution could translate information from one high resource language, for example, English, into a target Ghanaian language, right? And that could be a solution that you'll be providing for this hackathon phase and for this impact track. Okay, at step 4, we have the language task. And with the language task, this is where you would want to be connecting your problem to a specific language technology. Okay, so you and your team members should be asking yourselves, what must the system understand? What must it generate or retrieve or even extract? Okay, does the system need to understand what the user is saying? Does it need to retrieve existing information? Once you're able to answer some of these questions, then you have an idea of the language technology the language task that your solution falls under. Okay, so once you are able to identify the language task, then you'll be able to understand what kind of technology that you actually need to develop that solution you are thinking of. Okay, then that brings us to step 5, which is where we are asking ourselves, what technology enables the task? Okay, so this is where you can have some of these language technologies, machine translation, speech recognition, text to speech, information retrieval, information extraction. You may even use language models or large language models. Okay, now this technology you are choosing should be in response to the language task or tasks. Okay, because it could be that the solution you are thinking of would combine a number of language tasks to get you that one solution. So it gets you thinking and helps you to be able to identify the right technology for your solution. Okay. Then, as you know, we are supposed to also design a prototype, some sort of prototype, right? So you should be asking yourselves, what can we realistically demonstrate? Remember that it's a hackathon, right? So you will need to demonstrate that the idea that you have, okay, it works and then it addresses a real problem. So the goal here at this point, or within the time frame you have, is to be able to build something that is useful, feasible, and then inclusive. Okay, so we move on to some key concepts, okay, in this impact category. As you are thinking about the solution, you should be thinking about some of these things and where your solution falls under this particular impact track or category. Okay, natural language processing. Now, natural language processing is one term that you hear about as you discuss AI or language technologies, right? Now, in the simplest form, natural language processing is the use of computational methods for understanding and generating human readable text or speech. And I put or speech in brackets because, yes, natural language processing could extend to speech. But as I said, or as I mentioned, the morning session took us through speech technology. So our focus for this particular session is to look at the written language processing technology that is just has to do with readable text or text. Okay. And there are two parts of natural language processing. The first part is language analysis or natural language understanding. And then the second part is language synthesis or natural language generation. Okay, so when it comes to natural language understanding, we are concerned with taking language as input and then extracting some useful information or meaning from that input. So a user, for example, of your solution could say, my money has not arrived. Okay, now your solution, which becomes an NLP system, could analyze the sentence that the user has brought in, right? And then identify several pieces of structured information. For example, it could determine the intention of the user, okay, which could be, let's say, a complaint. Or it could also extract some information, transaction, a topic, for example, of that utterance the user has made, and realize that your NLP system could categorize that as a transaction, or it may be looking for a sentiment in the statement the user has made. And you'd realize that that sentiment is what? A negative sentiment. All right. So you'd realize that we go under natural language understanding, we go from human language as input to structured information that a computer can work with. Okay. Then we move on to the other side of natural language processing, which is natural language generation. Here, instead of taking in language and turning it into structured information, what you would provide to your system would be structured information, and then that NLP system would then generate language that a human can understand. So, for example, structured information such as type and then status, right? The type is transaction delayed, and the status is processing. Then your NLP system or solution could say, the output is your transaction is still being processed. At this point, we've gone from structured information to human language, which is very, very natural. Okay. If you don't understand what natural language is the language you and I understand. So humans communicating, right? As compared to what would use to instruct computers, that is programming languages, C++, Python, C#, and so on and so forth, right? So that is what we mean by natural languages. Okay, so we move on from understanding these major parts of an NLP system to the capabilities that NLP systems need. We can also think about this in terms of tasks, okay, that NLP systems can perform. Then again, I would say that your solution could be a combination of a number of tasks. Okay, so you could look at all of these and then break it down to understand, okay, I will need this, I will need that, I'll need that to build one wholesome solution, right? Or application that speaks to the problem you've identified. Okay, so then let us look at the capabilities. We have it in two sections. Let us look at the first part, which is capabilities that fall under natural language understanding. The first one we'll talk about is classification. Okay, and in here, we are looking at how we can take in some texts, or how your NLP system or solution can take in some text, and then decide which category it belongs to. Okay, so for example, if we have customer messages, we might want to classify them as a complaint, a question, a request, or a feedback. Okay, then we can have text extraction as a task. Okay, so here in text extraction, what we are trying to do is we are trying to identify information that is present in a particular given text. Okay, so if someone says, I want to send 500 Ghana cedis to my sister tomorrow, what your NLP system or solution will be doing, okay, at its core, is that it will be looking for potential information, okay, such as amount, recipients, and then intended date, right? Then intent detection. Okay, that's another task. That's another capability that your system can have, or a solution can have. And at this point, we are looking at what does the user want. Okay, so for example, if a user says, I forgot my password, I can't log in, then your system might be able to identify that the intention of this user is to reset the password. Okay, and intention detection is very important. It becomes very key when you want to develop, for example, a conversational system. Okay, something like we have something like a voice assistant. So you have Siri, for example, Google Assistant on your phone. When you tell Siri, unlock my phone, Siri needs to identify what action you are trying to accomplish before it can act on that. So it becomes very, very important, okay, when you are thinking of the way you want to design your solution. Okay. Now, the next task is sentiment analysis. Okay. We are looking at how, in this task, we are looking at how users express themselves. Okay. And usually you would have sentiments being grouped under three parts, either a positive sentiment, a negative sentiment, or neutral sentiment. Sentiment analysis tasks are also sometimes known as opinion analysis. Opinion analysis. Okay. Then the next thing is finding similarity in task. Remember that all of these things, you realize that it comes natural to us as humans, but then these are real challenges when it comes to NLP, right? And these all present opportunities for you when you are thinking about your problem and how you can be innovative in the solutions that you are going to be developing, especially in this track. Okay, so finding similarity. In finding similarity, we are looking at the relationship between texts. Okay, so for example, if you have thousands of people that are submitting some questions to your system or your solution, you may want to identify the questions that have similar meanings. Okay, you realize that I could say, you could have, okay, how do I change my password? I can't remember my password. These are two different statements that could mean the same thing. Okay, or that have some similarity when it comes to meaning. So although the wordings are different, the underlying meaning is similar, and that is the goal for similarity detection tasks. Okay, then we also have okay, so I think one place where you can adopt similarities is when you want to develop a solution such as a recommendation system or a document matching system. Okay, it comes in handy. Then we also have recognition. Okay, and recognition sometimes it's also known as the named entity recognition task. So here, what your system seeks to do is that it wants to identify who or what is mentioned in a piece of text. So if somebody says, or either says, MTN Ghana opened a new office in Accra, then what your system can do is that it can identify MTN Ghana as an organization and identify Accra as a location. Okay. All right. Then on the other side, we have generation and transformation. So the first capability we want to discuss is question answering. Okay, question answering or answering questions. So here the system receives a question. The user poses a question and then it provides a direct answer. So, and a question could be, what time does the clinic open? Then the system might say, this clinic opens at 8 p.m. or 8 a.m. Okay, then we also have text generation. Okay, so with text generation, your solution would be creating new text based on some input or instruction. So this could include, say, generating a response to a user question, drafting a message, or creating some other content. Okay, and you realize that large language models have become very, very prominent or popular in this regard. Then you could also have a system or a solution that does summarization. Okay, so with summarization, you would have a very large amount of information, and then you provide a shorter version that would communicate the information that is in the very long form of the document. Then you could also have translation, machine translation. So in translation tasks, we are converting from one language to another. Okay, and then the goal when it comes to translation is that you would want to preserve the meaning. Okay, so in translating information from a source language to a target language, you need to ensure that the meaning of the statement is preserved. Okay, and that is also a challenge. Okay, when it comes to language technologies. Okay, then we could also have the last category, which is correction. Okay, an NLP system, you can develop an NLP system that can identify and correct spelling or grammatical errors, right, within a system. Okay, and then in terms of simplification, which is another capability, what happens is that your system takes in information that might be difficult to understand for the user, and then it breaks it down in simple terms. So, for example, you have, let's say, a user, your system takes in some medical documents, okay, which contains very technical terminologies, and it's generally difficult for the general audience to understand, of course. So your system takes in the documents and then it transforms that information into a simpler language, right? That's the general audience can understand. So these are all things that or building blocks that you need or could use for your solution. Okay, now that we understand some of these NLP tasks, another area that is closely related to NLP is conversational artificial intelligence, okay, or conversational AI. And with conversational AI, they enable computers to interact with people in a meaningful way using natural language. Okay, so an example of this technology is chatbots or conversational agents, right? The important thing that your system or your solution would need to do is to be able to understand what the user is saying, determine what it can do or what it should do, and then communicate the appropriate response. So we can think about it in three stages: understanding, acting, and then responding. Okay, at the first stage, which is understanding, at this point, what your user will essentially do is that typically the user will send a message through whatever channel. It could be a website, a mobile application, whatever form or shape that your final solution would be in. And then once the system gets the user's raw inputs, okay, the system would now have to understand that particular input, okay, determine the user's intention, and maybe, extract some additional information that helps the system to understand the situation, right? Then once it has that understanding, we can move into the second stage of conversational artificial intelligence systems, which is acting. Okay, so at this point, the system understands what the user wants from the first step. Okay, but then the system now needs to determine what the application is actually allowed to do. Okay, so in there, you would have your business or application logic coming. Okay, and these application logic would need to determine what operations are allowed, okay, and be able to retrieve the appropriate information and then provide that information to the language system. Okay, then once the language system is able to retrieve relevant information, it can then generate a response for a user. Okay, so now the system will be able to communicate the results back to the user in a very useful way or in a very clear way. Okay, all right. So one category of conversational agents you can think about, which you can develop for your ideas, is chatbots or dialogue systems, question answering systems, right? And then intent-based systems or task-oriented systems. So you can think about how your solution would take shape. Okay, from the slide, you can see a sample or example conversational AI workflow. Okay, so this could be the shape in which your solution can take. Okay, so you have spoken language, that is sound. Okay, your user speaks to your application or your solution, then you'd realize that we have automatic speech recognition coming in to be able to capture what the user said. So the user from the automated speech recognition system, we could detect that the user said, "Please pay Dr. Leach $1,000." Okay, then from using that speech technology, it comes down into the language technology, right? The NLP aspects where the system will try to understand what the user has said and what they need to do, right? Once they understand that they know the user's intention, they're able to grab some information that is needed for understanding what the user wants to do. Then they can go into the business logic and actually perform some actions, right? Once the actions have been performed, then they can generate a response. Now, because we want to have like an end-to-end speech system, or that is the design of our solution, you'd realize that when the system, the language technology generates, say, okay, for example, let's say, I'm sorry, fam, you don't have enough cash, right? Then we could have that pass through a text-to-speech system, which will then convert the text to speech, and then it gets back to your user. Okay, so when you think about these conversational agents, these speech bots, okay, Siri, these voice assistants, Siri, okay, and co, you could think of them working in this manner. So if you have an idea that you think you'd want to develop in this field, then you should be thinking of all of these speech and language technologies, right? In this regard. Okay. Then moving on, large language models. Okay, and large language models have become very, very popular, right? They are a type of artificial intelligence models that are trained on very large amounts of data. Okay, so with these types of artificial intelligence models, they are able to learn from language data. They learn patterns in the language, and then they can use that pattern to perform so many tasks. Okay, so they can generate tests, they can answer questions, they can summarize information, they can translate information, and then many other tasks that you may be aware of. Okay, so examples of these models include GPT, Claude, Gemini. Okay, please can you still hear me? Can you still hear me?
Yeah, we can.
Okay, great, great. Thank you. All right, so these are all examples, right? So now, one thing is that remember that this is a hackathon, okay, and then you have limited time in coming up with your solution. So if you think that the idea you're coming up with you would use or would need an LLM, you would realize that it does not automatically mean, or it doesn't automatically mean that you need to train a model from scratch. Okay, so I'll explain like categories that I've put there. Okay, there are like several different ways that you can use an LLM in this stage, right? However, the approach that you want to use would depend on the problem you're trying to solve, the solution you're trying to come up with, and then the resources you have available. Okay, and one of the important resources that you do not necessarily have available is time. So you need to have an understanding of these things so that when you're deciding on how your solution will take shape, you factor some of these things in. The first thing is that we have pre-trained large language models. Okay, these are available. So at this point, if you want to make use of these pre-trained models, you pick them as they are. You don't make any modifications to the model. You provide some instructions to these models, and then you get some responses. So, for example, if you want your model to summarize a paragraph, okay, for your idea or for your solution, then you can ask it to do that. Okay, so with pre-trained models, you don't need to do so much, but it comes with some cons or some disadvantages because then some of the if it's open source, then some of the weights, right, may be large, and you may need some compute resources to be able to get you to run inferences from these models, right? Yeah. But then we can have prompt engineering. So now that's another approach. So instead of you giving the model basic instructions, you and your team could carefully design instructions that you want to give to the large language model. And then you would find that you would have better results. Okay, so the whole idea when it comes to prompt engineering is that better instructions can provide more useful and consistent results. More useful and then consistent results. So keep that in mind. Okay. So, well, you have some time during this hackathon. You can experiment with it and see whether it helps you when you are designing a solution. Okay, or whether it gives some results that you may want to adopt into your your solution. Now, the third one or the third approach you could consider when you are developing solutions that have to do with large language models is in context learning. Okay, so in context learning, you still write some prompts, right? But then you are telling the model what you want by providing it with examples. So we have concepts like zero shot, one shot, few shots, right? Few shots prompting. So zero shots, you don't give examples. One shot, you give one example. Few shots, you give a number of examples, right, to the large language models, and then you'd realize that you're not changing the model's parameter, okay, but then you're giving it additional information, and then you may find that you may get more expected results. Okay, moving away from that approach, you can also consider retrieval augmented generation. Okay, and retrieval augmented generation, which is normally or usually called RAG, is very useful when you want to build a model to use information that comes from external knowledge sources. Okay, in fact, RAG, one of the reasons why RAG became popular is that initially when these large language models were developed, right, or when they came into existence, you'd realize that these models used to hallucinate a lot. So one of the ways in which we wanted to reduce some of these hallucinations was to introduce RAG, where we feed these models with some verified information or external knowledge. And then these models are able to answer more confidently from the external source that you provide to it. So that is also an approach that you can have. So, in this regard, your when you use this approach, your user could ask a question to your RAG system, and then the RAG system would then retrieve relevant information and then provide it to the LLM of your choosing, okay, and then be able to provide more contextualized answers. Okay. Then the last approach you can consider is fine-tuning. Okay, now fine-tuning is where you want to adapt the model using a task-specific data set. So, there are so many general purpose models that are available. Okay, you'd realize for whatever problem you've identified, it may be the case that the domain, okay, the domain in which you want to work with may not be available. But then what you can do is you can fine tune an existing general model. It could even forget about domain. Sometimes it could be that even the domain is available, but then the language, the target language. Remember that the Ghanaian languages we are targeting for this hackathon are low resource. So it's possible that if you want to develop a solution for the Ever community, for example, it could be that there's that solution in English or Akan, but then there's none for what Ever. That provides an opportunity for you to make some innovations there, right? But then because it's like, the existing model is for Akan, now you need to think about how you can adapt the model for the use case, your target language, or for your target domain. Okay, and fine-tuning becomes very, very handy. Okay, so instead of us changing instructions, right, we'd rather train the model further on examples that are relevant to your task or domain. Okay, and then you can get them, you realize that the model may do better, okay, or more, would perform better than you would have. Okay, it's very at this fine-tuning stage, it's very, very important that you have high quality data sets. Okay, so that your resulting model is of good quality. Okay, one thing I would want us to also understand is that it would be very good if you think about your solutions very well and do not overdo things. Remember, you don't have so much time because fine tuning could take some time. Okay, and so if you realize that you explore prompt engineering and then that is able to solve your problem very well, then you realize you may not even need RAG, okay, or you may not need fine tuning. Okay, so these are some of the considerations you need to have when you're checking that. And then one thing I'd also want to also mention is that we have so many models. I'll introduce us to some platforms where we can find models, right? You realize that there are so many models out there, but you need to have some sort of checklist. Okay, you need to consider the language requirements for your intended solution, the task complexity and the domain. Okay, what exactly is your system do? Once you understand that, you'll be able to choose a large language model for your task. Because whether it is pre-trained, prompt engineering, in context learning, RAG, or even fine-tuning, you need to identify a model you want to work with for your task before you can choose any of these or adopt any of these approaches for the building or the design of your solution. Okay, you need to also think about the budget and resource costs. So computing, storage, and infrastructure. Okay, and even whether the models are available for access, inference speed and latency. Okay, the context window. Okay, the context window of the model you are choosing. How much information does the model need to consider at once before it can make an output or provide a response? Okay, so all of these things are considerations you should have when you are at this point. Okay, so building or reuse. Okay, you should be asking yourselves as teams, do we actually need to build everything ourselves? The answer is usually no, especially because it's a time-bound hackathon, right? So you may want to use, adapt, or integrate, or even build a model. All depends on the problem you've identified, the solution, and the resources you have at hand. Okay, so these are all broad approaches we can take. When we talk about use, you realize that most of the times the capabilities that you want your system to have is already there. You want a user to be able to speak to the system, okay? And then you realize that ASR technologies exist, automatic speech recognition systems already exist. So you may want to use them, okay, in this case. So they're already APIs. That's in the case that these models are not open source, they are closed. Okay, then you can make use of APIs, tools, and data sets that already exist. You don't have to start from scratch. You'd realize that it would save you a very significant amount of time. Okay, then you can also adapt. Okay, so in adaptation, um, these things already exist. Okay, but then you have to tweak it a bit to fit your problem domain. Okay, so you could do so through the prompting we talk about, prompt engineering we talked about, RAG or fine tuning. These are all adaptation methods. Or if you have custom data, you can use that custom data to improve the system for a particular user use case, or domain. Okay. Then when we talk about integration, as I said, when we looked at the speech conversational AI systems, we realized that it adopted speech technologies, language technologies, and so many other things to bring us one solution. So you may realize that the solution you are building, may need to combine different components together to get you that solution you are thinking of. Okay, so for example, you could have, say, a speech recognition model that will convert a user's speech into text and then send that text into a language model to understand the user's request, perform that request possibly, and then come out with an application logic and some response to the user. Okay, so these are all things you need to consider at this stage. Then the final option is building. Okay, so building, at this is the point where, okay, you've considered your solution, you know what you need, but you realize that what is available, uh, it doesn't really meet your needs, right? So that's when you have to consider the last option, which is building. Okay, so you could develop custom components, a custom data set, or a particular unique functionality. Okay, that does not exist. So if it doesn't exist, then that you can then build. Okay, but given the timelines we have, that you should really think through. Okay, what the resources you have before you get to this stage, and if you do get to this stage, um, you may have to put in more effort to make sure that your solution comes out in the time that we have. So building everything from scratch can be a very poor use of your time. So you need to think critically about the solutions you are coming up with. Do extensive research to ensure that at least you can solve your problem with the three approaches that we are recommending to you. Okay. Now, you need to design for the resources you have. Before I go on, please, do we have any questions? Do we have any questions? Hello, am I audible?
Yes, please, you're audible.
Oh, okay, great. All right. So you need to design for the resources you have. When you're thinking about this stage, as you are coming up with information for your abstract and thinking about the kind of technologies you need to also be thinking about the resources you have. Okay, so what resources do you have available? Okay, and what might be limited? And we can look at it in terms of 4 areas. The first one is data. Okay, most AI systems, most language technologies depend on data very heavily, very, very heavily. When we talk about these pre-trained models, when you read about them, you realize that the amount of data that has been used to develop those large language models you have available is crazy, right? So data is very paramount. Okay. So because many language technologies depend heavily on data, um, if for example you want to train or fine-tune a model, you may need you may need to be able to scout for some amount of information. Okay, it depends on your task anyways. Okay. Um, you'd realize that as I've already explained, the language data for the domain we are working with in this hackathon is no resource, it is scarce. Okay. It may not even be high quality, right? So you need to be thinking about this. So you need to be answering questions such as does this data exist? Okay, and even if it exists, does it have the right kind of the data that exists? Is it adequate for the task that we want to perform? Okay, you need to have that in mind. Then the second aspect is models. Okay, so for some languages or specialized domain, there may not be a very good pre-trained model available. Okay, so for example, you may find that many models may perform well in English, but then there will be few models that perform well in a particular targeted Ghanaian language. Okay, and this would affect the choices that you have available for your solution. So you need to have this considered very well. The third one is evaluation, because how do you know the language system, the NLP system you've come out with is good enough, okay, for use. Okay, and then that is where evaluation comes in. So you'd realize that because the languages that are being considered for this hackathon is low resource, there's usually a lack of benchmarks for these languages, and then it is something that um, you need to really, really consider. That you should be able to consider, right? So you need to take that into accountability. Are there benchmarks for evaluating this particular technology that I have come up with? Okay, and it becomes very, very key in certain domains. So, for example, when you take machine translation in a health sector, okay, it could be that when you test with your team, everything sounds very, very logical, but then maybe if you generalize to a user, an actual user, you realize that it wouldn't be doing well. And for you to be able to know, okay, or have some assurance that your model will do well when it's deployed in real world settings, you need to have an understanding of the particular evaluation benchmarks that are available, especially for your target language. Okay. Then the fourth one is the context. Okay, so general purpose models may know a lot about the language. It could be that there's a model that speaks Akan. Okay, and this model is great for Akan, but then it may not have specific information that you need for your application. Okay, so although the model understands the language, it does not know specific terminology. So if you want to provide a solution in legal or education or healthcare or agriculture, right? These are all very subdomains or very specific niche or domains, and these general purpose language technologies may not speak to that. So you need to, as you're talking about, either adapt these general purpose models or tweak it a bit to get the particular context of conversation you want to have. Okay, so all of these things could be limiting factors. Okay, so you shouldn't design your solution based only on what would be ideal, but you should look at what the resources you have realistically available before you start putting together what you think would be a very realistic solution. Okay. All right. So on the previous slide, we've looked at some of the resources that can be of limits to us, or that could be limited to us. Okay. When we are developing our language technologies, the question here becomes, what can we actually do about these limitations? So this slide gives us some practical guidelines, right? So the first one is the reuse of multilingual models. And the reuse of multilingual models, there are models out there that you can reuse. The DCS HI Lab has some models that you can, they may not speak to your domain, but they are available, okay, in some of these targeted language models. You could have, depending on the task, okay, the NLP, the technologies or the task that your system will do, okay, you would find that you need to go research on specific models that are available. So an example of a multilingual model is NLLB, No Language Left Behind. They have that model in different parameter or weights, right? Or sizes, let me just say sizes. And you could adopt them for your solution. It has a CAN and so on and so forth. So you could adapt these multilingual models for your work. Okay, so you can build that. Okay. Then collecting of targeted data. So at this point, you need to, if the data is scarce, then what do you need to do is either you collect data on your own, which could be time consuming, right? Or you could also reuse existing data sets. And depending on the problem or domain you have at hand, you could look at some data sets. Okay, then again, the DCS HCI Lab has some data sets available in some of the targeted Ghanaian languages that you may want to model your solution for. When it comes to the health sector, the DCS HCI Lab has some maternal health data. Okay, and that data actually is it's a parallel data set for machine translation tasks. So if if your solution would be handling machine translation, then you could consider such a data set for that. Otherwise, you could have we have another data set, CAN sentiment analysis corpus. Google Small, SMOL data set is also available. CAN emotion corpus data sets available. JW300 data sets available, although that one is biased to religion. Okay. The first one we spoke about, which is the DCS HCI Lab parallel data set, which is on maternal health data, is also biased to healthcare, particularly maternal health data. Then you could also consider Afri Health question answering or Kiwi data set. So all of these ones are existing data sets that may come in handy for you, depending on your problem domain and your target language. Okay, so you should have that in mind. Then, yes, so we could also look at RAG. Okay, as I said, with RAG, you may consider that if you want to augment your language model with some external data so that the responses become more relevant to the domain you are speaking to. Okay. Aside from RAG, you can also use existing models. Okay, you can adapt existing models. We've already spoken about this. Okay, so you can fine tune, for example, in regards to the status if the multilingual models or the models available are not they don't speak to your problem domain. Okay, you can look at that. Then you can also validate with intended users. That is very, very key. Okay. Especially because we are designing inclusive tech, or we are coming up with inclusive technology. So just because it's working technically, it doesn't mean that it would work for the people you're designing for. You need to always keep your intended users in mind, keep them close, and then work very, very closely with them. Okay. So all of these things would help keep your prototype very, very focused on the solution you want to have. Okay. Moving on, I would want us to consider some things. Okay, building responsible artificial intelligence systems. Okay, this is a section that is usually overlooked, right? But then when you're building an AI system, particularly one that is going to be used by real people, um, your responsibility shouldn't end when the model produces an output. No, you need to ask yourself some questions. What data are we using? How is the system representing the people in their language, right? Very, very important. What happens when the system is wrong? And one thing is that what are the consequences of the model getting the responses what wrong? Okay. So when you're building AI systems, right, for different languages and for different communities, you need to consider things such as the bias, the representation, and then the cultural context. Okay. So you could have that um, your solution works great. It supports the target language. Technically, everything is great, but then it wouldn't automatically translate to mean that the model is representing the language well. Okay. And so, for example, you could have a multilingual model, okay, that claims to support a particular target Ghanaian language. Okay. Even so, even if you test it a few times and you can confirm that okay, maybe it does support the language, the target Ghanaian language of interest. You still need to go beyond that and ask yourselves some questions. How well, okay, does this model actually perform in that language? Does it even understand the way people naturally communicate? Does it handle different variations of the language? Remember that language could have different dialectal differences. If we take Akan, for example, we can have Fanti, we can have Kwewu, we can have what? Asante, Asante Chi. I'm talking about Chi, right? Ekuapim Chi. All of these are different variations of the same language. So you need to ask yourself whether this system or this model that you are picking or this solution you have designed is able to handle different variations of the language. Okay. Does this system you're designing understand local expressions? Does it preserve the intended meaning? Okay, so that when your system is translating for a user, okay, you don't go ahead and misinform, the user. Okay. One other thing you also need to consider is that does the solution you have developed, does it behave appropriately within cultural context? Okay, does it do that? Okay, right. You need to consider all of those things as you are designing and building your solutions. Okay. The next area is output. Okay, and in the era or in the use of generative AI systems, you realize that these are one of the biggest challenges that we currently have. So um, you'd realize that these generative AI systems, right, or these large language models, they're able to provide information that sounds convincing, but then when you examine or analyze the information that these LLMs are providing, they could actually be incorrect. Okay, and this is a concept that you may have heard, hallucinations. And this was very, very evident in the earlier large language models or pre-trained models that were available to us. Okay, so you'd realize that many a times these systems will not even talk about the fact that they are not sure of the answers they're giving. They just keep generating answers that seem correct, but then are actually not correct. Okay, so these models um, they would produce confident sounding answers, right? But then the information they are providing could be wrong. So when you're designing a solution, you need to take all of these things into consideration so that you find ways and means to curb some of these ones or some of these hallucinations by the system. Okay. Now, you also need to think about how you can manage incorrect or harmful output. So, for example, if your system or your solution is generating creative content, okay, then an incorrect answer could be very, very inconvenient to the user. So you need to take this into consideration. Okay. If you are also building a system that provides information about healthcare, finance, education, agri, in the legal sector, all of these are very important areas. Okay. And especially in healthcare, if you have that your solution is providing incorrect answers, then it could have very serious consequences. Because let's say your solution is supposed to make recommendations for maybe anything at all. Could be something health-wise, right? And then it fails to make the right or approved recommendations, then it could have very serious consequences on your user. Okay, and that will lead us to thinking about the impact. Okay, so we need to ask ourselves, what happens when the system gets an output wrong? Okay, think about this very carefully. You shouldn't ask yourselves, oh, what happens when my system works? No. What happens when it feels as well? You should be anticipating some of these things. Okay, so suppose that your system translates a sentence incorrectly. Okay, what happens? If you are designing, your solution comes in the form of a chatbot, and then it gives some wrong information. What happens? If your speech recognition system you speak, the user says, I need money, then it says something else at all. Like it gives a different utterance at all, right? Which misunderstands what the user said. Then what happens? Okay, you realize that if you start to think about these things, you realize that the answers will depend on your application. Okay, the application you are designing or the solution you are designing. Okay, so the level of responsibility and safeguards that you need to implement within your solutions you are designing it should reflect the potential impact of the system. Okay, that it would have on your users. Please, do we have any questions? All right, so moving on, how do you choose the right NLP technology? Okay, we've looked at some concepts. We looked at language technologies, NLPs, conversational AI, large language models, right? And some considerations for responsible AI. But then, how do we bring these? How do we choose the right technologies? Okay, how do we know the capabilities? We've already seen some of the capabilities. How do we know which ones we need? How do we know which ones we need? So you need to start with the problem then again. Okay, just as we spoke about in the previous slide, you identify your problem, you identify what the user needs, and then you can then identify what the system needs to do with a particular language, and then finally choose the technologies. Basically, I recommend we think about these flows when we are trying to choose the right NLP technology for our solution. Okay, so the first question we have on the slide is the system understanding text? Is the system understanding text? And this could correspond to NLP capabilities or tasks such as classification, intent detection, extraction. In fact, language detection is another task that you can also consider. Okay, so if your main requirement or your main goal for your solution is to analyze or understand text, then this is one category of capabilities you should be thinking of, or NLP tasks that could be embedded within your application. Okay, so for example, you are receiving customer messages And then you need to determine whether each message is a complaint, a question, or a request. Okay, you'd realize that is a classification problem. I've already explained this one previously. Okay, you can look at intent detection, you can look at extraction, okay, information extraction. Okay, so under this, we should be thinking, what information do I need to get out of the user's language? Okay, think about this. What information? So the target language that you have for a solution, what information do I need to get out of this language? And then you'd realize that this is the category you should be thinking of. Then is your solution generating or transforming text? Okay, so if the system needs to produce some new text or transform existing text, then you may want to consider large language models or text generation tasks or summarization. Okay, over here. Okay, an example is that you have, as I was saying previously, you have a long document and you want to provide a shorter version of that, and that is the core goal, or that is the underlying goal of your solution. Then you could consider a summarization. Your solution can be categorized under what? Summarization. Okay, so another thing is your solution converting between languages. Okay, if it's converting between languages, then instantly it means that you are drawing towards, or you're moving towards the machine translation aspect. Okay, now it could be that LLMs can translate, can perform these tasks, but then you shouldn't automatically choose. I think you should first ask yourself if there's a machine translation model or service that is designed for this task, okay, and whether it supports the need. Also, in terms of machine translation services, you can also look at APIs from Google Translate. Okay, it may also be something that you can use while you are or consider while you are building your solution. Okay. The fourth question you could ask is, does my system at any point in time need to find information? If your system needs to find information, then you should be thinking of information retrieval and RAG. Okay, your solution could be using some of these technologies for these tasks. All right. The fifth question is, does my solution or any part of my solution interact with users? And if it does interact with users, then it means that your solution will need to have conversations with the user, and so you may be considering dialogue systems or conversational artificial intelligence systems. Okay. So in these systems, as we've already established, the system might need to understand the user's message, identify their intention, retrieve some information, or perform some action and then generate some words, some responses. Okay. Yes, then does my solution or does our solution need to work with a specific language or a domain? Okay, it's very, very important for this hackathon. So because we are building solutions for Ghanaian languages and possibly persons with disabilities, you need to consider these things very, 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 very well. Okay, does the technology support the language very well? Okay, as a team, with the solution you're coming up with, are you working with a specialized domain? Is it healthcare, education, agri, finance, legal? Okay, does the system have knowledge and technology required for that domain? Okay, so depending on the answers you provide to us, so depending on the situation, you might consider multilingual models, you might consider fine-tuning or leveraging custom data. Okay, as I've already established, fine-tuning may not always be the answer. So you need to first of all determine what your actual limitations are, and then decide as a team on the best technology that you need to adopt for your solution. Okay, so these are solutions, sample solutions. This is not an exhaustive list. It's sample applications that fall under this track. Okay, so if you are thinking in lines of this, then it means that your solution is in line with this track. So dialogue systems, conversational systems, machine translation tools, writing assistants, text summarization tools, question answering systems, information extraction tools. Okay, if you think that the solution you are going to be developing will fall under any of these things, then you have that your solution is under that. Okay, so dialogue systems, they are designed to support interaction between people, a person who will typically be a user in the computer system, right? Then conversational agents, okay, they would be answering, they also interact with the users, they answer questions, they provide information, provide guide users through a process, okay, or even assist them, okay, in completing a particular task, right? The machine translation tools, they will convert content from one language to the other. Okay, so you could have that, okay, you want to solve a problem where there's information available, let's say news outlets, okay, whether these news outlets or advertisements, this is an example anyways. These advertisements are done mostly in English, right? So you want to have a tool that can help someone who speaks only Ga, for example, to be able to understand some of these advertisements that are made in um, that are made in English language, right? So machine translation will be a technology that you adopt, and you could develop a tool for that in that regard. Okay. Writing assistance. So this becomes helpful, right? These are tools that your users can use while they write, correct, improve text. These writing assistants could have spelling and grammar corrections. They could suggest alternative words or help users to produce text. Okay, so your solution can fall under this, and once your solution falls in line with this, then you should be thinking about this impact category. Then text summarization tool. So it takes one big, large chunk of information and then it condenses it into a shorter version while it's preserving very salient information. Okay. So if you are going to be developing something like a text summarization tool, then this is the category for you. Question answering systems. Okay, so the user asks a question, the system provide an answer. Okay, that falls under this category as well. Information extraction tools, they also are tools that fall under this particular domain or this particular impact track. Okay, so let's assume that you want to build. So let's assume you want to build a Ghanaian language customer service assistant. You realize that this is your target solution or application, and this application would use several capabilities that we already talked about: the intent detection, language detection, emotion detection, uh, sentiment analysis, right? All of these things, just that solution can adopt that. So if we take the customer service assistant, it may use speech recognition to understand the user's voice. That is, if you want to make it an end-to-end speech tech, okay, and it becomes helpful for especially users that may not be able to read or write the target language, right? So it means that when they speak to the solution you develop, they can understand it right away, and then they can also get some responses back in their natural language, right? So it picks up your solution, which is the customer service assistant. It has speech recognition, which understands the user's voice, NLP to identify the user's intent, information retrieval to find the relevant information. Then you can use a language model that would help you to generate a response, and then you can have your text to speech system that would communicate the response back to the user. Okay, so you realize that one application would have so many things, okay, in there. All right. So platforms, models, and frameworks. Okay, now that we have an understanding of what technologies we need to consider when we are building our solution. Okay, the next question becomes, where do we as a team find these technologies, and then how do we use them? Okay, so you know, AI has become very popular, right? And you'd realize that you may come across different models, different APIs, different platforms, different frameworks, hosting services, and hubs, right? Which can be a dilemma. It can be quite confusing, right? Especially if you're new to this. Okay, and these things they serve different purposes. Okay, so I have this slide included so that you are aware of some of these things in regards to some main categories that have to do with models, uh, accessing these models, hosting these models, and the platform frameworks that exist. Okay, so when we start with models, right, when you are choosing a model, as I said, you need to ask yourselves, what language capabilities do I need? What language task do I need? And once you have that, you realize that you need to select a model, okay, that performs the task that you are interested in. Okay, and there are let me say, two main types or two different types of models that we can consider. You can either go for an open source model or a proprietary model. Okay, open source models, their weights are available. Okay, you can even run them locally. You can download these model weights and then run them locally or use them locally or use them any other place where you may be running or developing your solution, right? So we have open source models such as Llama, Mistral, Gemma, DeepSeek, NLLB, as I spoke about. Okay, these are open source models that you'd find on certain platforms that I'll talk about shortly. Okay, one thing you need to be aware of that you shouldn't choose a model just because it is popular. Okay, start by identifying what capabilities you want your solution to have. Then you can then go to some of these platforms and identify models in regards to this. So, for example, you could say, okay, you want to develop a machine translation tool. That means that you would be doing some translation tasks. Okay, so you'd have to go through these platforms and look at models that are designed or that are capable for translation, right? If you need to do text generation, you may consider generative language models. If you are going to be doing speech recognition, right, you may consider speech recognition models that my colleague shared with us earlier on in the previous session. Okay, so the model selection comes based on the capabilities that you require. The next category we should be looking at is the access to the model. How do I even access these models? How do I access these models? So how do I access these models? You would at this point you've identified the model you want to work with or you want to adopt for your solution. Okay, but then you need to access in the sense that you need to find a way to communicate with that model from whatever solution or resulting application that you develop. And one common way you can access these models is using an API. Okay, so we have providers such as OpenAI, Google, Anthropic, Grok. Okay, and all of these providers, they provide access to models through APIs. And this comes in handy for proprietary um, models. Okay, some of these ones, they come in handy. But in the event that you also want to use uh, multimodal models, okay, or you want to access multiple models using a common interface, then there are other platforms such as Open Router. Okay, and Open Router, in fact, Open Router is free to an extent. Some of the models that are available on Open Router is free to access. Okay, so you may not need an API key or purchase API keys as you would, for example, in OpenAI or in the case of Gemini. So you can check out Open Router. Okay, so you realize that some of these services will provide access to models using a very common interface. Then now that we've been able to identify models and how we can possibly access these models, okay, we look at hosting, okay. Then again, also remember that aside from APIs, as I said, you can download some of these pre-trained models and work with them in your local computer or in whatever setting you find environments that you use for training your model or developing your solutions. Okay, so that's one way we can consume these models, and then once, let's assume you fine-tune your model, okay, uh, to have a version, your own version of a particular pre-trained model, right, that you have evaluated and you think is good, right, as per the evaluation metrics that you identify, then you can host these things. You can host these things. So whether the model one, that is the hosting. So in terms of hosting, you can look at cloud GPUs, okay, Ramport, Lambda. Okay, these are cloud GPUs. You can look at hosted inferences. You can look at Together AI. You can look at Replicates. Okay, all of these ones, they may come at a cost. Okay, so you can do your research and then pick ones that are affordable to you. And then you can also host it. You can self-host it or have it locally done on your own computer. So you can have a GPU or CPU or your own computer that you would be running your models from. Okay, so it depends on the model, its requirements, and the computing resources that you have at your disposal. Okay, I think when it comes to evaluation as well, usually the evaluation benchmarks that are available, I think I mentioned it earlier, the evaluation benchmarks that are available, they do not necessarily fit into this low resource language context, and that becomes also a challenge, okay, when you want to evaluate your solutions. Then, yeah. And in terms of hosting as well, you can also quantize the model. I think in the morning session, my colleague mentioned quantization. Okay, so you want to keep the model weight smaller, especially if you want to be running with limited resources. Okay, keep it lightweight. Okay, and you can have considerations for budget and then resources as well, as I mentioned. Then we have the platforms. So the platforms is, okay, at this point, you've heard a lot. Okay, models, data sets, and so on. Where can I discover them? Where can I access these resources? One of these ones is Hugging Face. Hugging Face is quite popular. You will find models there. Okay, it provides access to models. You would find models there. You can access models there. Um, you would find data sets there. You can access data sets there, exist data sets. Some of the data sets I mentioned are on Hugging Face. So when you go there, for example, the Google Small data set is there. You can access it. Okay. Then have even on Hugging Face as well, you can even host your models there and even make inferences from there. So they have things like spaces where you can create some very simple interfaces where users can interact with the solution, or sorry, the model you may have fine-tuned or come up with, right, as part of your solution. Okay, then we also have Kaggle. Kaggle is another very popular platform. Okay, Kaggle provides data sets and tools. Okay, as a matter of fact, you can actually do your trainings there. Okay, you can do your trainings on Kaggle, you can do your trainings on Google Colab as well. Okay, but I think Kaggle is much generous with their resources that they provide. So you could consider that when you're building your solution. So aside from the fact that Kaggle provides data sets and some of the tools that you can use um, when developing your AI solutions, you realize that in recent times, Kaggle has also made provisions for models, okay, over there, okay, that you can also use. So you could find data sets on Kaggle. You can also find models there that you can use. You can run your trainings or developments over there on Kaggle when you are running some pipelines, right? So they are all available. And then you can also use some other AI ecosystems and toolkits. So you can also consider Google AI Studio, Azure AI, and then AWS, okay, Amazon Web Services. All right. So these platforms can give us access to models, development tools, data sets, and then computing resources, or other services that we may need while we are developing our solution. And then finally, we can think about frameworks. Okay, so frameworks will help us to connect different components together to build that one application. Okay, so you can consider frameworks such as LangChain, Llama Index, and then Haystack. Okay, and you can use these frameworks to connect language models with other components. And these other components could be retrieval systems, databases, application logics. Okay, uh, when you are designing your solution. All right. So I would want us, this like a more like a reflective thing. We'll take about 10 minutes to look into this. I don't know how many people have their team members on the call, but I'll give us some time to look at all we've discussed, the problem, the user, think about the problem you're trying to solve, think about who you are designing the solution for, think about the application you're proposing to build, think about the language tasks, the capabilities that we mentioned of that you need to build that application you're thinking of. What technologies do you need? Do I need speech technologies? Do I need language technologies? What kind of language technologies do I need? Do I need machine translation? Do I need information extraction? Do I need language detection? All of these things you can think about that. Okay, and then think about what you can realistically demonstrate using the current idea that you are proposing, at least for the option. So I'll give us 10 minutes for us to think about this, and I may take one or two opinions if you care to share. And then that will bring us to the end of the session. Before we go on that small break, do you have any questions to share, to ask about the presentation so far? Do we have any questions that we want to ask? Okay, since there are no questions, then I would
Hello.
say,
Hello.
okay, yes, hi. Yes, hi.
Please, are there some specific Ghanaian languages where there are little to no data sets?
I would say yes. I don't know all the Ghanaian languages that we have because we have so many of them, but it's possible that you would have a Ghanaian language that has little to no resources. For example, I don't know if you know about the language Ekoso. Do you know about Ekoso, for example?
No.
Exactly. That I also didn't know about that, but then the HCI lab at the computer science department at the University of Ghana have made available some resources, but then it's not a very popular language even here in Ghana. So assuming that the lab have not done some research into collecting data on this, then it would have been very, very possible that that would be a language, because it could be that that is a language that someone in your team may speak, but then you will not find data on that. At least that is existing unless you take the pain of doing your own data collection, which is also what time consuming for the kind of information you have. So I would say it's very
Yeah.
possible, yes, that you would want to have a target language you want to model for, but then you are struggling to find resources in terms of data to support the solution you want to develop. Any other questions? Any other questions? All right, so if there are no questions, as I
Please,
said,
last question.
okay, okay,
Um,
please go ahead.
please, how realistic is it, right, to have more than one, like utilizing more than one language in one system?
Oh, it's very realistic. That is why there are multilingual models available. So I gave an example of this NLLB, no language left behind model, right? It's for machine translation. You'd realize that it supports many languages. It supports many languages. So it's very, very realistic. But then the question you should be asking yourself is that with the time frame you have and with the resources you have, right, are you going to be able to develop a multilingual model, a multilingual system that speaks to the problem you are solving. Realistically, it's possible, but then you should be thinking about your time and the resources you have available to that effect to be able to decide as a team whether this is realistic for this hackathon. I don't know if you understand what I'm trying to say.
Yes, please. Yes.
Uh-huh. Yeah,
And
so
one
it's
last
possible you
question.
can have multilingual model. Yeah.
Okay. Please, one last question here. Please,
Mm.
in the local languages, you see we
Yeah.
have data sets for code mixes where we have English and um
You mean
Chi or
code
any local.
switching?
You said
Where a particular, I'm saying, are you asking about code switching where a particular input sent by a user could be English and Chi at the same time?
yes, or
Is
in
it
this
something like that?
case,
Okay, okay.
English, in this
Mhm.
case, Chi and let's say Ga.
Okay, yes, yes, yes. Uh-huh. What's your question?
Yes. Are there data sets that would help you with that? If they
Yeah, so you
if they
would,
this one, if they let's say the user in a sentence like uses words that are peculiar to English, Ga and peculiar to what's it called? Chi.
so your if I get you right, your question is it possible to develop a system that can tackle code switching, or at least a part of your solution would handle code switching? Is
Yes,
that your
please.
is that your Yeah,
Yes,
it's
please.
possible. It's possible. But then again, consider the resources at hand. Whatever your the languages you are going to be decided on, do you even have data that would help you to even train a model or fine tune a model to say, oh, when somebody says me ko school aba, right?
Yeah.
School sounds okay. I'm going to school, but remember CCR, something like that.
Yeah.
Do you even have data that will help you to either fine tune or develop a model that will help you to identify these patterns?
Yes, please.
So that's where the challenge comes in, right? So you need to think about it very carefully. Okay. So please take your time. When it's 5:50, I'll take some responses from us and then we can go. Okay. If you are at liberty. If you want to share, that's fine. Okay, so we'll do that in the last session and then we will move on. Thank you. So 5:50, I will meet. Anyways, I'm on standby. So if you have any questions while you are trying to um, go through this process of coming up with your solutions or possible identifying the technologies you need in the idea you want to develop, then I'm on standby. I can answer these questions. Thank you. So 5:50. Hi, I think that is up. Is there any volunteer that would want to share with us what they've been able to come up with, what their solution is? Okay. Um, okay. I mean, okay. It shouldn't. Okay, I think I should have added this. It shouldn't be maybe your idea for now because, of course, it's a competition, so you may not want to put it out there. So I think it could be any ideas you have that relates to anything as well. It could be a popular problem, okay, that you think you can follow through with this cycle for you to be able to identify what technologies you need, at least language technologies in particular, to be able to get a solution. Is there anybody that would want to share anything in that regards with us? Okay. All right. So, okay. Since nobody would want to share with us, I think that's fine. What I would finally ask is that if we have any questions or contributions, um, then again, any final questions, any final contributions that we want to um, put to bear. Hello, can you hear me? Hello, can anyone hear me?
Yes, please.
Okay, okay,
Yes,
okay.
we can hear
So,
you loud and
all
clear.
right, all right, great. So, if we do we have any questions, any contributions to make with regards to the presentation for this evening session? Okay, since
Oh,
there's
you people, at least say something. At least say no
okay.
or say yes. Just say something. Hey, you're making her feel like she's talking to herself. Mm.
All right. Anyways, okay. So I guess there are no. If there's something in the chat. Okay. I guess there are no questions or contributions. So I'll say thank you very much for joining today's session, and then all the best
All right. Thank you
on
very much, Ms.
your work.
Akosua, for an insightful presentation. I hope the teams or the attendees in today's meeting can make good use of it. Please, you know our tradition already. All right, they're already giving you your accolades. So that means they have major take homes
Thank
from
you.
today. All right, so thank you once again, and we hope to meet more of you as the teams progress through the several stages of this hackathon. All right, teams, so we continue tomorrow with UX and UI sessions, morning and evening. So, in the absence of any questions or contributions, I wish you a lovely evening and see you all tomorrow. Bye.
Bye.